Hello everyone, I'm Zeenath Jaha Begum from MLR Institute of Technology. Today I'm going to discuss about one of the important topic of automata and compiler design, that is conversion from NFA to DFA. So in the previous lecture, we have discussed about what is NFA, non-deterministic automata, and also we discussed about the deterministic finite automata. So after that, this is the main important topic, how to convert non-deterministic finite automata to a deterministic finite automata. So before going to the deep brief description about the conversion of NFA to DFA, first we just have a go through the topic, what is NFA and what is a DFA. So coming to the NFA, non-deterministic finite automata. So it is a finite automata where each and every state can have more than one transition. That means it can have zero transition or it can have more than one transition. Whereas when coming to the deterministic finite automata will have from each and every state exactly one transition will be there. So this is the major difference which we have from NFA as well as the DFA. Now coming to the actual topic, conversion of NFA to DFA. So conversion of NFA to DFA generally follow with these 4 steps. So what are these 4 steps we are going to see, and also we will follow with the help of one example. So before seeing the steps, as we already know that a finite automata will consist of 4 to 5 tuples, that is Q, summation, transition function, Q naught as well as F. So capital Q stand for what? Set of states. Summation stand for the number of inputs. Transition function stand for exactly the formula of the transition function. Q naught will be the initial state as well as the F as the final state. So here, whenever we are converting from NFA to DFA, here we are taking the 2 set of tuples here. One is M, another one is M dash, such that there is we can say that L of M is equal to L of M dash. L is nothing but the language. That means language of M is equal to language of M dash. So here why we are taking M dash is for nothing, for as we are converting from NFA to DFA. In that case, here we are going to take, that is nothing but that is the symbol that is known as the M dash. Now coming to the steps here. So here we have to follow with the 4 steps. So initially Q naught is equal to 5. So that is nothing but the number of states which are present while converting from NFA to DFA. Initially here we are taking as 5. Then second step, here we are adding Q naught of NFA to Q1. That means here we are taking the NFA state and here we are forming the transition function from the starting state. Now coming to the third step. In the third step, we see as Q dash, where all the possible states of each input symbol, whereas if the states belongs to the Q naught, then it is going to be added. If the new states are going to be generated, then we are going to find with the new transition function for that. And finally, step 4, here it will declare with the DFA, where all the final state will be the state which contain the F symbol. That means, for example, if Q2 is the final state, right? If Q2 is the final state, so wherever the Q2 is present in the DFA, that will be also considered as the final state. So this thing we will understand with the help of one example here. So let's take one example. Here we take one example here. Convert the given NFA to DFA. Now, first we are going to see that whether the given problem is in NFA or not. So as according to the NFA definition, what is the NFA definition here? That is, for each and every state, it can have 0 or more than one transition. So that is nothing but that is known as the NFA. Now here, if you see here how many states we have? Here we have 3 states, that is Q naught, Q1 and Q2. So Q naught is what? That is the initial state. Yes. because initial state will be represented with the arrow, and Q2 is nothing but that is known as the final state. So if we can see here in the transition diagram, Q0 we have with a 0 input as well as Q0 we have with the 1. Okay, that means here the input symbols are 0, 1. Now coming to the next state, Q1. Q1 with 0 we are having with the Q1 itself as well as Q2. That means from Q1 with 0 as an input we have two transition. One is Q1, that is Q2. So this is the easy way of finding whether the given problem is in NFA or not. So this type of a problem NFA we have to convert into a DFA. So let's see with the solution here. Okay, here for the given transition diagram, the first step what we are going to do here, we have to write the transition table for that. Okay, so what is the transition table consist of? Transition table consists of state as well as the input symbol. If you can see here the question here, in the question they didn't specify with the input, but by seeing the question we can say that the input symbols are nothing but 0, 1. So here a transition table, this is known as the transition table. So transition table, so for the above question given in the problem, first we have to write the transition table for that. So transition table consists of states, inputs as well as the transition function for that. Now how many states are given here? 3 states, Q0, Q1 and Q2. So Q0 is what? Q0 is the starting symbol. So as we represent in the diagram what is the starting symbol as well as what is the final symbol, final state. Here also in the table we have to represent that whatever it is the starting state as well as whatever it is the final state. So Q0 is the initial state, that is represented with the arrow, and Q2 is the final state which is represented with the star, or else we can simply double circle also. That is it. If you are representing star, no need of giving a double circle. Now we have to find the transition function for the transition diagram. So here, now from Q0 to 0, what we have from Q0 to 0? We have Q0. From Q0 to 1 input, what we have? Q1. In the same way, from Q1 to 0, what we have? Q1, Q2. See here, Q1 of 0 is Q1. Again, Q1 of 1 is nothing but that is Q2. In the same way, Q1 of 1 is nothing but, you can see here 1 itself, that is nothing but Q1. Now final state, Q2 of 0, Q2 itself, Q2 of 1, Q1, Q2. So this is a transition table for the above transition diagram. Okay, next step. Now find the transition function for that. Okay, so for the normal, generally we denote with the transition function as this symbol. Now as we are converting into NFA to DFA, we generally use the transition function with the symbol that is dash, right? So it is very simple to understand that. Already we have defined in the table. The same thing here we are defining with the help of the transition function. The same thing. So transition dash Q0 of 0, Q0, Q0 of 1, Q1. So here what we have to observe that if we are getting any new state, because already in the points which we have mentioned that if we are generating any new state, for that new state we have to again generate the transition function with the help of input A and B. Yes. So here, what are the old states we are having? That is Q0, Q1 and Q2 at left hand side, right? Apart from Q0, Q1 and Q2, if we are getting a new states, so that state will be considered as new state. So for that new state, you have to form a transition function for that. Now here, already we have described transition Q0, 0 is Q0, transition dash Q0, 1 is Q1. Now next one, after Q0, what is the next state we are having? Q1. So Q1 of 0, what is Q1 of 0? Q1, Q2. Now check it out, Q1, Q2. What is Q1 comma Q2? That is new state. Why we are saying it's a new state? Because if you see the table here at the left hand side, do we have Q0, Q1 combinedly? No. You have to observe here at the left hand side. No. So in that case, we can say that this state is known as the new state. Now again, it find out for transition Q1 comma 1. What is Q1 comma 1? Q1 itself. This is what? This is the old state. So no need of writing anything for that. Now coming to the next part. Next state. What is the next state we are having? Q2. Q2 of 0. What we are getting? Q2 of 0. Q2 itself. That is a old state. Next. Transition of Q2 of 1. What we are getting? Q1 of Q2. That already here we have specified that this is a new state. For example, instead of Q1 comma Q2, if we got like this, Q0 comma Q1. So this is also known as the new state. We can write as new state. Okay, but already here Q1 Q2 already we got it here. So that's why we are not mentioning any new state here. Now, I think up to here it is clear that first what we have to do, first we have to find the transition. We have to write the transition table for the transition diagram given. Then we have to go right with the transition function. Now from the transition function, we have to find with the we have to find with the new states. So whenever we get a new state, for that new state, we have to again go with the transition with the inputs A comma B. Here. Now you can see here. Now we will obtain transition dash on Q1 comma Q2. Why Q1 comma Q2? Because it is a new state. Here. Again, with what? With 0 as well as 1 as an input. Okay. Sorry. Here by mistake I have written A comma B. That is nothing but 0 comma 1. Next. Again find it for Q1 comma Q2 of 0. So what is Q1 comma Q2 of 0? Here you have to use the operation that is known as the union. So individually you have to find Q1 of 0 union Q2 of 0. Now see from the table, what is Q1 of 0? Q1 Q2. What is Q2 of 0? Q2. Combinedly you write it and what you are getting? Q1 and Q2. Is this state is new state? No, this is the old state. Why? Because already here we are generating the new state and we got the same as an same state. So this is nothing but this is the old state only. In the same way, transition of Q1 comma Q2 of 1. So Q1 of 1, transition of Q1 of 1, union transition of Q2 of 1. Q1 of 1 is nothing but Q1. Q2 of 1 is nothing but Q1 comma Q2. When we combinedly, if we do with the union operation, we get it as Q1 comma Q2. That is also the old state or a same state which is generated. For example, instead of Q1 comma Q2, if you get Q0 Q2, that means this is again it is a new state. So in that case, you have to find again the transition of Q1 Q2 of 0 and also Q0 Q2 of 1. If you get a new state apart from that. So we didn't got any new state, that is the old state only. So up to here we have derived the transition function. Now the last step. What is the last step? Here we have to draw the transition diagram. That is that thing, but that should consist of a DFA. Now, how many states we are having now? How many states we are having? First, Q0, that is Q1, Q2 and Q1 comma Q2. So the one important thing is that whenever you are converting NFA to DFA, the number of states, if suppose the number of state is 3, in DFA it will be 3 plus. That means whenever we are converting NFA to DFA, the number of state will be increased compared to NFA. If you can see here, previously we got in the problem we have 3 states, that is NFA. Now when we are converting to NFA to DFA, we are having 4 states. That means the number of states will get increased whenever we are converting NFA to DFA. So you can see here how many states here we are having now. We are having with the 4 states. So for the 4th state, whatever the transition you got, write in the form of a table. So this table is nothing but this table is known as the transition table. Now this table we have to convert into the form of a transition diagram. Now one more important thing you need to observe that in the last point we say that wherever we have a final state, wherever the final state is there, the final state should be marked. That means in our previous question, what we have the final state Q2. That means wherever the Q2 will be there, that complete state will become also as the final state. That means if you can see here, we are having 2 final states here. One is Q2, another one is Q1, Q2. Because Q2 is present here. Now we'll see the final output here. Transition diagram. So here you can see here 4 states. Here this is the initial symbol. Q0 is the initial, right? Now from Q0 to 0. Now how to see whether it is a DFA or not? DFA means each and every state should have exactly one transition. See here, one transition. This is also considered as one transition. Then only we can say that it is a DFA. So here Q0 to 0, Q0. The same way Q0 to 1 is going to Q1. Q1 of 1 is going to Q1. Q1 is going of 0 is going to Q1, Q2. Again Q2 of 0 is Q2. Q2 of 1, Q1, Q2. In the same way self loop Q2, Q1, Q2 with the self loop of 0, 1. This is known as DFA. So this is the thing which we have seen the steps how to convert from NFA to DFA. So the 4 important steps here which we can say is which we can define. First thing, whatever the transition, whatever the question is given, for the given question, first you have to, for example, if they given in the form of the language, first you have to draw the transition diagram for that is NFA. Then for that NFA, what you have to do, you have to write the transition table, then go with the transition function and find the new state. If you get a new state, for the new state, you have to write a transition with the input, whatever the input is given in the question. For example, here it is given with the 0 and 1. So you have to find a transition with the 0 as well as 1. Then once you get a transition, if you don't find any new state, then simply you can stop there and you can just simply draw the transition, write the transition table. And for that transition table, you have to write the transition diagram. Okay. So we'll see with one example here, second example. So here it is given as transition diagram. So transition diagram consists of what? 2 states here. One is Q0, another one is Q1. So according to the previous problem, what we have seen here, first we have to go for the transition table. So transition table consists of what here? States, that is Q0 is the initial state and Q1 is the final state. So wherever the initial state is there, you mark with the initial state. Wherever you have the final state, mark with the final state. Now according to the diagram, Q0 of 0. What is Q0 of 0? Q0 itself. Q0 of 1, Q0 of 0 is Q0 as well as you have Q1 also. Now Q1 of 1, what you have? Q1. Yes. Next, Q1 of 0. Do we have Q1 of 0 here? No. Simply you can write 5. Next, Q1 of 1. What is Q1 of 1? We have Q1 as well as Q0. So this is the transition table for the above transition diagram. Okay. Now what we have to do? We have to write a transition function. So I'll write here transition function. So transition function consists of what? Transition of q naught of 0. Q naught of 0 is nothing but q naught comma q1. Next, transition of q naught comma 1. Q naught comma 1 is q1. Next, transition of, what is that? q1 of 0. q1 of 0 is what? q1 of 0 is nothing but 5. We don't have anything q1 of 0. Next, transition dash of q1 comma 1. That is nothing but q0 comma 1. Now here you can see here how many states we have. Actually 2 states. Now apart from that, here we got a new state. So that is known as, that we can write it as new state. Now what we have to do according to that? We have to find the transition for the new state. Yes, so we can write as transition of q0 comma q1 of 0. Next, transition of q0 comma q1 of 1. Now what is transition of q0 of 0? How we have to write? Transition of q0 comma 0 union transition of q1 comma 0. Yes, what is q0 of 0? What is q0 of 0? q0 of 0 is nothing but q0 q1 union q0 of 1 q1. What is the answer we are getting here? q0 q1. Now in the same way, transition of q0 of 1 union transition of q1 of 1. Next, transition of q1 of 0 is nothing but 5 union q1 of 1. What we have? q0 comma q1. What is the union we are getting? q0 comma q1. Do we get any new state? No, the old state is generated. Now how many states we are having now? How many states we are having? 3 states. q0, q1 and q0 q1. This is starting. This will become, as well as this will become final state. Why? Because q1 is present here. 0 1. q0 of 0. What is q0 of 0? q0 q1. q0 of 1 q1. q1 of 0 5. q1 of 1 q0 q1. q0 of 0 q0 q1 of 0 q0 q1. q0 q1 of q0 of 0 q0 q1 of 1 will be again q0 q1. So this is the transition table for the transition function. Now the final output. So the final output consists of what? 3 states, q0 q1 and q0 q1. What are the final state? q1 as well as q0 q1. So for the final state, we are just we are making as a double circle. q0 of 0. What is q0 of 0? q0 q1. What is q0 of 1? 1. What is q1 of 0? 5. So for the q1 of 0, we don't have anything. So for that, we can introduce one state that is known as the dead state, and we can give a simple as a 0 transition. So whenever in the DFA, if we don't have any transition, so simply we can introduce a one state that is known as the dead state. Dead state is nothing but no transition will be there. So simply we can write 0. q1 of 1, that is q1 of 1 is nothing but q0 q1. q0 q1 of 0 and 1, it will be same self loop 0 comma 1. As well as it is a DFA, even in the dead state also, we can have we can have a self loop and we can give a transition with the input 0 comma 1. So this is the final output. So how many states were there? In the question we got 2 states. But how many states we got as an output? That is 2 plus. That means 4 states, including what? Including the get state. So this is the conversion of NFA to DFA. Hope you understand the problem. Thank you.